I am Nirmala. I am working as an assistant professor in the Department of Physics in Vahu Vajiha Women's College, Koyalpatnam. This e-content is developed using PowerPoint, and it is a course on the basics of electricity. In the course, we are going to cover basic concepts like electrolysis and the important law which supports this electrolysis. I would like to say about the basic ideas like what is a cell and the different types of cells and why we are really in need of various cells. In the forthcoming session, we are going to start with the topic electrolysis. Here, we must be familiar with three terms, namely solute, solvent, and electrolyte. For this, we have to consider the salt, namely copper sulfate. When copper sulfate salt is dissolved in water, water is called solvent, copper sulfate is called solute, and the solution is called electrolyte. When an electric current is passed through the electrolyte using two copper plates as electrodes, copper gets deposited at the negative plate called the cathode, and sulfate gets dissolved at the positive plate called anode. This is what explained with the help of the diagram. And thus we can define electrolysis as the chemical reaction that takes place between an electrode and an electrolyte. Now let us move on to the next topic, which is about the law which supports the electrolysis. The law which supports the electrolysis is called the Faraday's law. The Faraday's laws, with the help of two equations, explain this electrolysis. These are the equations are given. One is M directly proportional to I and T. Here, M is the mass of the element liberated by electrolysis with the quantity of electricity through electrolyte, and I is the current, and T is the time through which the it is passed through electrolyte. And the next equation is E equal to M, where E is the electrochemical equivalent and M is the mass of the substance liberated during electrolysis. Next, we move on to the special topic, which is cell, which is about cell. A cell is a device that produces an EMF across the electrodes so as to supply electric current to an external circuit. And it can also be said as it converts chemical energy into electrical energy. There are two types of cells. One is primary cell and the other is secondary cell. It is explained with a simple primary and secondary scale diagrams. Next one, what is actually a primary cell? What actually a primary cell do? In primary cell, the cell ceases to function as the chemical fuel is exhausted. The internal resistance is high and it cannot be used to draw steady current. And finally, the EMF across its terminals remains almost constant. Leclanche cell is an example of primary cell. Here are the various parts and the various electrolytic name given. And Daniel cell is also another primary cell. Here how the Daniel cell works and how it helps to explain how it helps to glow a bulb is given. And third one, standard Cadmium cell. Its various parts and its entire diagram is given. Finally, we are going to discuss about the secondary cells. These are storage cells. These cells are also known as reversible cells. These cells can be charged any number of times. Here, the internal resistance is very low and hence a large current can be drawn from them. The examples are lead acid accumulator, and another example is nickel ion alkali cell. And now I come to the summary of the entire session. First, electrolysis. Electrolysis is nothing but a chemical reaction that takes place between an electrode and an electrolyte. And the main law behind this electrolysis is Faraday's law. It was explained with the help of equations. And finally, we discussed the cell, which is a device which converts chemical energy into electrical energy. And now I have framed an assignment based on this electrolysis. What are really the strong electrolytes, weak electrolytes, and non-electrolytes? Try to attend this and find a success. Thank you.